see today we are going to see change of variables from Cartesian to polar coordinates. Okay, so very fastly I shall give the important points to remember in this. So in this you have to know the Cartesian coordinates means x comma y. The Cartesian coordinates means x comma y, and the polar coordinates means r comma theta. Okay, so if we want to transform from Cartesian to polar means we need some transformation. So for that we always assume x equal to r cos theta and y is equal to r sin theta, and always you will have dx dy or dy dx that will be equal to r dr d theta. Here also r dr d theta. Okay, so these things are common. So generally when you are considering double integration, so here you are taking double integral f of x comma y dx dy or double integral f of x comma y dy dx, whatever it is, you will have double integral f of r cos theta comma r sin theta comma r dr d theta. Here also you will get the same thing, f of r cos theta comma r sin theta comma r dr d theta. So how you are getting these formulas means it is simple. Suppose if I am taking double integral f of x comma y dx dy equal to, always you will have the some transformations means you will get some Jacobian f of r cos theta comma r sin theta. So here you will have some Jacobian into dr d theta, where this Jacobian is dealing with the transformation from x comma y to r comma theta. Okay, x comma y to r comma theta, that is you will get dou x by dou r, then dou x by dou theta, then dou y by dou r into dou y by dou theta. If it is so, then you will get dou x by dou r. So x is equal to r cos theta. When it is differentiated with respect to r means you will get only cos theta. With respect to theta you will get minus r sin theta. Then y with respect to r means you will get sin theta, and y with respect to theta means r cos theta. So on taking a determinant you will get r into cos square theta plus sin square theta, so that is equal to r. In the same way, if you want to calculate the Jacobian for y comma x with respect to r comma theta also, you will get the same result. Let me show that also. So Jacobian j equals, suppose if I am transforming y comma x to r comma theta means, then also here also you will get dou y by dou r, then dou y by dou theta, then dou x by dou r into dou x by dou theta. So in this also you will get y with respect to r, y is equal to r sin theta. So y with respect to r means you will get sin theta, then y with respect to theta means r cos theta. Here x with respect to r means cos theta. Okay, x with respect to r means cos theta, and x with respect to theta means minus r sin theta. Okay, so you will get you will get, you can take the Jacobian like r into, or you can take like this, minus r into sine square theta, then minus r into cos square theta, that is equal to minus r, okay, minus r into, since we are taking Jacobian, modulus of determinant of Jacobian, you will get determinant for everything. Okay, you have to keep that in mind. You have to get a determinant for everything. Okay, you have to keep that determinant for everything. So you get minus r into sine square theta plus cos square theta, that is equal to determinant of minus r, that is equal to r, that is equal to r. Okay, so you have to keep in mind, you are taking determinant of Jacobian. Okay, you are taking the determinant value of Jacobian. So when taking the determinant value of Jacobian, this modulus of j, this modulus of j, this modulus of j will become r for both dx dy and as well as dy dx. Okay, that is why you are getting, that is why you are getting the same kind of response for both dx dy and dy dx. That is why both these are equal to r dr d theta. Okay, r dr d theta. So now we are going to see some problems regarding circles. Okay, some problems regarding circles alone now we are going to see. For example, in circles especially we are going to see the problems under Cartesian circles, the problems under Cartesian the problems under Cartesian coordinate to polar coordinates we are going to see. We are going to see the problems under concentric circles. Okay, problems under concentric circles. See, for that I am going to take one circle. Okay, this is one circle and I am taking another circle, and I am taking another circle. Okay, so first one is one circle, second one is another circle. See, both the circles will have the same center, both the circle will have the same center. Okay, will have the same center. This is one radius and this is another radius. Okay, so let it be like small, let it be like r1, let it be like r1 and let it be r2. Okay, so a complete small capital radius is r2, the long radius is r2, small radius is r1. Now I am going to fill, inside with the yellow color. Okay, circles with same center but with different radius r1 comma r2, center C. Okay, r1 comma r2, that is r2 greater than r1. The two circles with same center C but with different radius r1 comma r2, that is r2 greater than r1 is called concentric circles. The area or region, region or portion portion covered by the difference of these two radius. Difference of these two radius that is R2 minus R1 is called annular region. You can use small a also. Annular, A-N-N-U-L-R, annular region. Okay, so you have to know this. So if R2 is making the area, pi R2 square and R1 is making the area pi R1 square, means then the annular region area of annular region equal to pi of R2 square minus R1 square. Okay, so the difference between these two radius will form one area. This is called annular region. Okay, so for this type of problems we are going to transform the variables from Cartesian to polar coordinates. So for that we have to take the axis line. Okay, for we have to take the axis line. This will be our x-axis and this will be our y-axis and this will be our x dash. This will be our x dash and this will be our y dash. So when you are discussing about R, okay, R, you will have some theta also. So that will be 0. Here it is 90. Here it is 180. Here it is 270. Again here you will have 360. If something is covered only on first quadrant, your theta varies from 0 to pi by 2. If something covers both the upper half, that is both first and second quadrant, means it will be 0 to 2 pi. Okay, sorry, 0 to pi. Okay, 0 pi by 10, 0 to pi. If it covers both the upper portions, okay, then both upper quadrants. After that, if it comes down, means it will be 0 pi by 2 pi, then it is 3 pi by 2, and after that this is 2 pi. Okay, so 0 pi by 2, then pi, then 3 pi by 2, then again 2 pi. You have to remember all these things. Okay, now we are going to see our first problem. So take the first problem. Dear students, the problem is very important. The problem here is evaluate double integral over the region R. They have mentioned it as region. Very good. In the we are having xy dx dy divided by root of x square plus y square by converting into polar coordinates where where R is the first quadrant, or is the first quadrant, or is the first quadrant part of the region bounded by two circles. One is x square plus y square equal to a square, and second one is x square plus y square equal to 4a square. X square plus y square equal to 4a square. X square plus y square equal to a square. X square plus y square equal to 4a square. Okay. Now we shall move on to the solution. So dear students, can take down the solution part. Let x is equal to r cos theta, y is equal to r sin theta. You are having dx and dy, so you will get dx dy equal to r dr d theta. Okay, everything is fine. Then you are having x square plus y square. When x equal r cos theta, y equal r sin theta means this will imply x square plus y square equal to r square cos square theta plus r square sin square theta, that is equal to r square of cos square theta plus sin square theta, that is equal to r square. Therefore it implies x square plus y square equal to r square. Okay, this is also one thing you are having, and this is another thing. Okay, then remaining things are these two, x equal to and y equal to. So these things are need to be substituted. These things are needed to be substituted in the given problem. Okay, now we have to identify the region. So in order to identify the region, they have given a point, region bounded by two circles. One circle is x square plus y square equal to a square, and another circle is x square plus y square equal to 4a square. So we have to draw two circles. Okay, we have to draw two circles. See, this is one circle, and then this is another circle. Okay, this is another circle. Both of them are sharing the common center. Okay, both of them share a common center. These type of circles are called concentric circles. These type of circles are called concentric circles. Okay. Okay, these type of circles are called concentric circles. Okay, now we are having x here, x dash here, y here, and y dash here. Okay, now they want us to find the region bounded by two circles. Okay, we have to find the region bounded by. So you have to just change the word in your mind. Region formed by two circles means region formed between two circles. Okay, because there is one big circle and this big circle is covered by one small circle. See, you are already having one circle, and after that above that circle you are placing one more circle. Above that circle you are placing one more circle. So definitely the second circle will cover some area. The remaining area only you have to find. The remaining area only you have to find. Okay, so here your task is to find the area covered by yellow color. The area covered by this yellow color. So they have mentioned it as the first quadrant. They have mentioned it as first quadrant. So first quadrant means you are not required to find the other. You are not required to find this green color. Okay, you are so students, you have to always keep that in mind. Okay, okay. So this is your first quadrant. Okay, this is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. In first quadrant you will have, see, I am taking two radius. This is one radius small a, because they have mentioned it as, they have given the equation of circle. What they have given equation of circle? X square, first circle. Okay, one is small circle, small circle or inner circle. Inner circle is given as x square plus y square equal to a square. Okay, then big circle or outer circle. Okay, outer circle is given by x square plus y square equal to 4a square. They have mentioned it as 4a square. What do you mean by 4a square? 4a square means that is x square plus y square equal to 2a the whole square. So here center is center 0, 0, radius equal to a. Here also center 0, 0, but radius equal to 2a. So this is a and this is 2a. Okay, so definitely you will have some theta for both a and 2a. Okay, definitely you will have some theta for both a to 2a. Okay, okay. For example, if I am considering small circle means it will have some theta 1. If I am considering this big radius, this big angle means this will have some angle theta 2. But dear students, you have to keep one thing in mind: both the circles are forming on the same center, only their radius is different. So at the same center it is traveling through the equal distance in all the four quadrants. So what the thing is, both this theta 1 and theta 2 will be equal to the same angle. Okay, because see, with the same center I am going to find the one angle. Okay, with the same center I am going to find the another angle. Okay, this is one common center. See, this same center is rotating. The same center we are going to change the angle. For second circle also the same center we are going to change the angle. So angle will be common for both the circles. Only thing is the radius is different. Okay, so you will not get two different angles. You may think like it will form two different angles, but the thing is you will get the same angle, that is this is also equal to theta and this is also equal to theta. Okay, so how the angle theta will be, will be the value of theta? Very simple. Theta is traveling from this part. Okay, theta is traveling from I am choosing some different color. Okay, theta is traveling from this angle. In this angle means it is very flat. Here theta equal to 0, then here theta equal to pi by 2, that is 90 degree. Here theta equal to pi, that is 180. Here it is 270 degree, that is 3 pi by 2. Pi by 2 means 90. 90 into 3 is 270. Then again here you will get 2 pi. Am I right? So from 0 to pi by 2 it is traveling. From 0 to pi by 2 it is traveling. Okay, so now you have obtained your limits. What will be our limit? One limit is, see, the limits are limits. So for this problem the limits are mentioned as or in Cartesian coordinate. They have not given any particular limit. Okay, Cartesian coordinate limit. Okay, and that is region. Here it is not R. In polar coordinates you are having the limits of R is, see, limits of R means here the distance is A and here distance is 2A. So you are finding the region between, this is the region you are finding. So that is A to 2A. Our limit is A to 2A, and theta limit is 0 to pi by 2. So 0 to pi by 2. Now we have identified the limits, and now we are going to substitute everything here. Okay, everything here. So now you will get the result very soon. Okay, that is they have mentioned double integral over R, then xy dx dy divided by root of what they have given in the question, divided by root of x square plus y square. Okay, root of x square plus y square. Okay, root of x square plus y square, that is equal to, again double integral, x is equal to r cos theta, y is equal to r sin theta, divided by x square plus y square equal to r square. For that we need to take root. Dx dy equal to r dr d theta. Limits of r is a to 2a, and the limits of theta is 0 to pi by 2. Okay, now you are having r cube cos theta sin theta divided by r into dr d theta, then double integral a to 2a and 0 to pi by 2. Okay, that is integral 0 to pi by 2. This r cube and r will get cancelled. You will get only r square. R square. Here you are having sin theta and cos theta. So we know that there is a formula called 2 sin theta cos theta can be written as sin 2 theta. So for that I am going to multiply this by 2 and divide this by 2. So I am writing it as 2 sin theta cos theta divided by 2 into dr d theta. Here it is a to 2a. Okay, now the next thing is here integral 0 to pi by 2. Then you can take this 1 by 2 outside. 1 by 2 into 0 to pi by 2. Then you are having r square. So integrating r square with respect to r, this theta and all will act as constant, but we shall simplify it and after that we shall integrate a to 2a r square sin 2 theta dr d theta, that is equal to 1 by 2 integral 0 to pi by 2 into 0 to pi by 2 into, dear students, keep in mind here a to 2a is also constant because there is no theta involved. This 0 to pi by 2 is also constant, no theta involved. So you can write like this also. You can easily simplify this. Since these two limits are independent of their variables, you can split like this also. Sin 2 theta d theta integral a to 2a r square dr. You can write like this also because a and 2a are also constant. They are independent of r and theta. 0 to pi by 2 is also constant. They are also independent of functions r and theta. So since they are constant, you will be able to write like this. Okay, but as we are having some common practice, I am always prefer to use the common practice what we tend to teach, what I tend to teach always. Okay, always do with the fundamentals, always try with the fundamentals. Okay, advancement of something may give some errors. Okay, because the fundamentals will not undergo any errors. So I strongly believe that. So you please write like remaining terms are constants, so you will get, you can take it here outside, that is sin 2 theta into this r square integrating, you will get r cube by 3. Okay, r cube by 3. The limits are a to 2a into d theta, so that is equal to 1 by 2 into integral 0 to pi by 2 sin 2 theta. This r cube is 2a the whole cube minus a the whole cube by 3, that is upper limit minus lower limit, into d theta, that is equal to 2 cube is 8. 8a cube minus a cube means it will become 7a cube. 7a cube divided by, there is 3 and there is 2 outside, that is 6. 7a cube by 6. 7a cube by 6. Then you are taking this integral 0 to pi by 2 sin 2 theta into d theta, sin 2 theta into d theta. Okay, so dear students, now Okay, on integrating this you will get 7a cube by 6 into on derivation you will get minus cos 2 theta by 2. The limits are 0 to pi by 2. Okay, that is equal to minus 7a cube by 6 into cos minus cos 2 pi by 2. Okay, minus lower limit. See, we have already taken minus outside, so this is plus, then minus cos 0, cos of 2 into 0, that is equal to minus 7 a cube by 6 into cos pi minus cos 0 that is cos pi. Value of cos n pi equal to minus 1 power n, so that is equal to minus 1 minus 7 a cube by 6 into minus 1, then minus the value of cos 0 is 1. Okay, that is equal to minus 2. So minus 2 means it is minus of minus and minus will become plus 7a cube, that is here you will get here 2 in the denominator, you get 2 in the denominator, here also the 2 in the denominator, here also the 2 in the denominator, so you will get into 2, that is equal to 7a cube by 6. So this will be your final result. The final result is double integral over r x y divided by root of x square plus y square x square plus y square dx dy equal to double integral a to 2a 0 to pi by 2, that is r cos theta, that is r cube cos theta sin theta by r, that is r square. R square cos theta sin theta dr d theta equal to 7a cube by 6. 7a cube by 6. Okay, so this is your final result.